All right, so this is our first video in a short series on our fourth topic, sensation and perception. And I think as we go through this topic, you'll see a lot of connections to the things we covered in biological psychology, things about neural transmission, and the way that our brain is obviously very highly involved in all of our perceptual activities. So, to start out, I first want to make a very clear distinction between what sensation and perception actually are. So, sensation is what you are experiencing from the environment. It is taking the energy in the environment, whether it's molecules rubbing against each other to give you a sensation of temperature, whether it's light coming from the reflection off of a rooftop into your eye, the sound waves going through the air and touching different parts of the organs within your ear. All of that conversion of energy into something that you can actually use through your body as in terms of neural impulses is what sensation is. So taking physical reality and turning into a message that your body can interpret in some way. So the patterns that you see between light and darkness that you're seeing in your environment, the taste converting some sort of matter into a signal from your tongue to tell you if something is bitter, sour, sweet, whatever. These are all kind of examples of sensations. Perception, on the other hand, is the interpretation of that information. So if sensation is the letters on the page of a book, perception is you interpreting those letters to be sentences and words. So perception is collecting all of this these processes together that are going to tell us what the world is like. So sensation, let's stick with vision. It's always a very often used and common example. The light entering your eye and being turned into a neural impulse by the photoreceptors on your retina, that is sensation. You are sensing the light from the environment. But you being able to actually tell what you're looking at, your occipital lobe in your brain, turning those neural impulses into something that you can actually use and say, I'm looking at a tree. That is perception. You're perceiving that tree. Now, as you'll see as we go through these different terms and examples, perception is just how you are reading the environment. Like sticking with the book metaphor, if you're reading a book, you might misread something. You might misunderstand a word. Maybe you think it says though instead of thought. There are all kinds of mistakes that we make in a systematic way when we are turning our physical reality into something that we can think about and use in our everyday experience. And there are a lot of really kind of fun little, visual tricks that psychologists and, just other people in the world have used to kind of show how your perception can be a little, let's say, fuzzy or malleable in some ways. So this famous shape that you have surely seen in different places, maybe you've even drawn them yourselves when you were a kid, it's called the Necker cube. And depending on where you really look at the cube and the parts you're focusing on, it can completely change your perception of what the drawing is of. So if you are focusing on this square in the lower right as being the front of the cube, then you can see this is the front, this as a side, this up here is the top, and the back, obviously not visible to you, but the back is up higher than the front. But if you instead just focus on this upper right square as the front, then you all of a sudden can kind of see a cube going down and to the right. This is the front here, this is the right side, and this is the bottom. So which part of this that you are focusing on determines something about how you are perceiving this object. Another couple really kind of famous examples, this picture of, if you look at it one way, you might see an older woman, her nose here with kind of a bump on the edge of her nose, her eye looking this direction, her mouth here, her chin, some sort of frilly collar around her, and you can see this older woman looking off to the left as I have the picture here. But if you focus on different parts of this picture, in different ways, you might see something else. You might see a younger woman. So the younger woman's chin, she's looking off, kind of backward in the photo to the left. This wart or bump is not a bump, it's her nose, and her eye is somewhere here, not quite where we can see it, but looking back in this direction, what you saw is the older woman's eye is actually the younger woman's ear. And instead of this being her mouth and lower jaw and chin, this is the neck of the younger woman and a necklace going across. So the way that you are looking at this and what you are focusing on can change your perception again. And another, maybe slightly less interesting, but kind of famous one is an image like this, where if you look at certain types of space, like if you focus on the black space, you might see a vase or a pedestal or something like that. But instead of focusing on the black space, you can look at the white space, and then you might notice it's two faces looking at one another. So you can see how the building blocks of your experience, the sensations, are separate in a way from your perception of them. The way that you put those blocks together changes what you perceive in your environment. So in this unit, we're going to talk about several different senses. We'll focus a lot on vision because, again, those examples work relatively well to use to explain these things. But obviously, the traditional five senses: vision, hearing, touch, smell, and taste. But human beings, we talk about someone having a sixth sense as being sort of a supernatural thing, but really we do have many more senses than those traditional five. This is not an exhaustive list, it's just a few other examples, but there are more specific senses that we might kind of subsume into touch sometimes, like pain, nociception rather. Your balance, that's controlled by your vestibular system partly in your inner ear, is equilibrioception, how well you can keep your balance and be aware of that balance. Proprioception, the awareness of your limb position. So when you wake up, for example, and you don't know exactly where your limbs are because you haven't placed them there, you still have an awareness generally of where your arms and legs are and how they're positioned before you open your eyes. You're aware of that body position. You're also aware of the movement. We get feedback from our bodies to tell us that our arms are moving in some particular way, or that our legs are moving. And one example might be when you're running, you don't have to necessarily look at your feet the entire time, right? You can feel where they're going to go and trust that you're going to be able to put them in the right spot. And another one, thermoception, just the root word that means heat at the beginning there, just has to do with our feeling of temperature. And really, our feeling of temperature has more to do with change than it does for actually knowing how hot something is exactly. But again, these are just some examples to show you we do have many more senses and many more ways we are interpreting that sensation we're getting from the environment into some kind of perception we have of our world. So, to kind of figure out this relationship between sensation and perception, there is a subfield of psychology called psychophysics. And this area is really trying to figure out what the relationship is between the stimuli in your environment, the physical characteristics of light, of objects, of sound waves, of the molecules that our taste buds interact with, all these different things, and figuring out the relationship between those objects, those signals, and our psychological experience. So our senses are kind of bound to particular types of input. Your vision is entirely determined by the light that you are perceiving with your eyes. Volume and sound and hearing are entirely controlled by the sound waves that you are hearing that are going through the air and making different vibrations at different frequencies. Your feeling of weight associated with touch has to do with the pressure that you're feeling at a given time. And things like sweetness have to do with particular, again, compounds or molecules, like sugar being sweet, raw cocoa being bitter, salt tasting salty, lemon juice tasting sour. Those particular interactions with our taste buds and sensors in our mouths that interpret different molecules as being a certain thing or tasting a certain way. So we take these environmental impulses like sound waves or light or whatever, and we change them into neural impulses. And this process is called transduction. taking those physical impulses and turning them into something that we and our brains, more specifically, can interpret. So your eyes turn those light waves into neural impulses that get sent through your optic nerve back to your occipital lobe where there's interpretation going on. In the nose, there are different chemical reactions going from different molecules, usually gaseous molecules. Doesn't really work with solid or liquid things quite the same. And those gaseous molecules interacting with these different sensors in your nose are turning those signals into neural impulses, basically. Chemical reactions on your tongue from lemon juice has a different neural impulse than from sugar. And, one little grain of sugar is going to have a different impulse than a whole spoonful of sugar, for example. In your ear, the sound waves that enter, they're going to create some kind of neural impulse by touching, or rather impacting the different hair-like structures going on in your ear and changing, pressure inside of it. And your skin has a lot of different types of sensors and sensory neurons that are able to tell things like pressure, pain, temperature, and all these things are creating different types of neural impulses. And I'm going to stop there because then I'll explain this idea that we've kind of touched on already about bottom-up versus top-down processing as we start the next video.